Okay, so back to database. I'm in chapter 7 of the Chrome Key book. So I'm going to let you see the slides that he would have, but I've modified these quite a bit. Hopefully those will be fairly obvious. So today we're going to talk about outer joins, trying to give credit where credit was due. So it comes out of the Chrome Key in our book, chapter 7, but it has my modifications because we're doing online teaching due to COVID-19. So outer joins, we're going to have an example, we're going to talk about why it's important, and we're going to look at the join syntax. To set this up, because the book sets it up this way, we're going to go back to the ViewRidge Gallery database design. You may remember this. We went through this before break. Think hard. We had these tables, and what we're particularly interested in today are the fact that we have a customer, and customers are interested in artists, and this is a many-to-many relationship. A single customer might be interested in more than one artist. A single artist might have more than one customer interested in them. And with SQL, when we have that, we have to convert that many-to-many relationship into another table, specifically an intersection table. And this is a typical intersection table. It's got two columns in it, and they're the keys from the two different databases, or the two different entities. So we have a customer ID to tie it back to the customer table, and artist ID to tie it back to the artist table. So we're working with something a little more complicated than we have been for the most part here. So to really see what customer is interested in what artist, to get all the information, we've got three tables involved. The customer, which goes to the intersection table, which goes to the artist, or vice versa. Okay, so let's start by just listing our customers. Here's a nice simple SQL command to select. I just want the customer ID and the last name from the customer table, ordered by the last name. This is very simple. And the point is I get 10 rows here with the 10 customers. So there are 10 customers in the database. So far, so good. Nothing surprising yet. So we can ask a question. What do customers buy? Okay. We'd like the customer's last name and the artist's last name. And to get that, we have to work with the customer table, the artist table, and the intersection table. And this is the join the way I've been teaching you, where we say, hey, I want where the customer ID from the customer is equal to the customer ID in the intersection table, and the artist ID in the artist table is equal to the artist ID in the intersection table. And so if I do those two things, I should be able to get those connections. I'm going to keep ordering my examples by customer last name, just so that they come up in the same order, even if the SQL changes a little bit, so that it's easier to compare them. So there's nothing real special about order by. I just think it makes it easier to keep track of what's going on. So when we do this, we get these 28 rows, okay? And you can see that most of these customers, they've got interest in more than one artist. We've got Fredrickson, he's interested in 4 different artists. Gray, 3 different artists. Janes, 3 artists. Smathers, 3 artists. Smith, 5 different artists. Twilight, Twilight is the last name of a customer. 4 different artists. Warning, 3 artists. Wilkins, 3 artists. So, isn't that great? We could find that out. We could use some SQL. We could find something out. Is this correct? Is what I did correct? It depends. We had 10 customers a minute ago when I listed the customers. But if we look at this output, there are only 8 different customers listed in the 28 rows. Okay. So what happened to Johnson and Wu? Okay, we had 2 customers, one named Johnson, one named Wu. They didn't show up. Okay, so is our query correct? Well, it depends on what we want. So what we did, and what SQL default does, what SQL does by default, is called an inner join. Okay, to be included in results, there has to be a match on the identifying column between 2 tables. And this actually came up shortly before break. We had some example where we got something. I pointed out that what we were getting depended on this being an inner join, depended on the fact that it didn't list everything. With an inner join, that's the default. If there is no match, then the row is not included in the result. In this case, where we have a customer ID equal to the intersection table customer ID, If that doesn't get a match, then we leave them out. Johnson and Wu have not bought anything, so they have no matches in the customer artist intersection table. Okay, and therefore they're going to get left out. They're not going to show up. Is that correct? Well, it depends on what we want. If we only want to see what a customer bought, then we wrote a good query. But if we want to see what our customers are doing, then we're missing the fact that Johnson and Wu didn't buy anything. So depending on our purposes, this may or may not be what we want. What if we want to know what all of our customers are doing? We want to see something about each of the customers, and if that something is they're not doing anything, we want to know that, okay? So first we have to introduce some alternate syntax. This is called a join on syntax. Some of you tripped into this. I guess you looked around on the internet or wherever, you tripped into this on your own. You've been doing it, and that's fine. I never objected to it, but I haven't taught it yet. I don't really like it. I like the way I do it better. I think it's simpler. Some people think this is more understandable, but regardless of how I feel, the syntax that I like using only works on inner joins. You cannot get to work on an outer join. So here's our first exposure to the join on syntax. The select part, the columns are just the same. The table is just the same. Actually, this is funny because I used multiple tables. I only have one here. I know this query worked. I made this work before I cut and pasted it onto the screen. So it's filling the tables in for me. I wonder if I could leave that from clause out altogether. Maybe I could. But in any case, I've got this join clause, and I've highlighted the word join and the word on in red to make it a little more obvious to you. So what I've got is I've got a join, and I've got a table name, in this case, customer artist intersection, on, and I've got a criteria. What is the criteria to do the join? And the criteria to do the join is the customer ID in the two tables matches. This is very similar to what we did before, except we've got this join in here, okay? Now, and you know, actually, and this is why I don't really like the syntax, this word join is actually between two tables. What two tables is it between? It's between customer and customer artist intersection. You see that? It says customer join, customer artist intersection on, and it has the criteria. I find this hard to read personally, but it's what we have to work with to make this work. Now I've got another join. Why is that? I noted originally that we had to get three tables, three entities to line up, three tables to line up to get what we wanted. The customer, the intersection table, and the artist table. And when I've got three tables, I'm going to need two joins. So I've got the join that's between the customer and the customer and the intersection table. And now I've got a join between the artist and the intersection table. And that works about like you'd expect. So the join here, the second join, the table on the left is the result table from doing customer join with intersection. So it's the result of doing a customer join with intersection, and then I join that result onto the artist table, okay? And then I got my order by just to keep these more straightened out. And what does this do? This does exactly what our earlier one did. This is exactly equivalent. I get the same 28 rows. I still don't have anything for Johnson or for Wu. We're getting there. That brings us to the outer join. I just showed you an inner join with different syntax. Now I'm going to show you the outer join. The outer join lets us force each customer to have at least one row in the result. If there is no match on the join, we get a value from one table and a null to indicate no match on the other. So once I make it an outer join, I'll get at least one row even if there's no match, okay? Now, which table do I get the row from? Well, it depends, and we're going to see it. So we make something a join. This is the same syntax we had before for our second try, our join on version, except we've added the keyword left. We've added the keyword left in two places, and we can add either the keyword left or the keyword right. We'll get to right in a minute, but for right now, we've added the keyword left. Now, this join we mentioned is a join from the customer to the intersection table. We could read it, customer join intersection. Now we read it, customer left join intersection. And when we do that left join, it means that we will always have at least one entry for everyone in the customer table, including Johnson and Wu in this case, okay? And then we have another left join where we take the result of joining customer to intersection, and we join the artist to the intersection, and then we order by just to keep the order the same so we can compare them. And with this left join, what do we get? We get 30 rows, not 28 rows. And as you look down, we're going to see, there it is, Johnson. Johnson is now in the table, and they have a null for the artist that they like, okay? So when we joined to that intersection table, we didn't find anything. And then when we joined that all the way through the artist, there wasn't anything there either. So we pick up a null, but we do see it. So now we can be aware, Johnson, there's nothing, Johnson's not connected to anything. And the same with Wu. Wu is not connected with anything. Our outer join includes at least one row for each customer. Where there are no matches for the join, we get a null value. So now we can see what's going on with our customers. Is this what you want? Well, it depends on what you're trying to get, but we can see what our customers are doing. Let's take the same select, the same code, but instead of saying left join, we say right join, right join. And I've circled the word right to make it a little more obvious to you. And let's run it again. This time we get 29 rows. And what happens? Under the last name, we get a null, but we get a last name for the artist. So our outer join right includes at least one row for each artist because the artist table is on the right. And where there are no matches for the join, we get a null value. So in this case, we have an artist named Klee. And Klee is an artist who's never been bought. We have no customers trying to get Klee. So we've got two customers, Johnson and Wu, that aren't trying to get any particular art. And we've got one person, one artist, Klee, who we have in stock or he wouldn't be here, where nobody's interested in him. So what does this tell us? Well, if we're a salesperson or a manager, this information about Klee might indicate to us, hey, don't buy any more Klees. No one's interested. Klees we have now, they're not going anywhere. For a salesperson, they might say, well, gee, it's time to poke at Johnson and Wu and see if we can get them interested. They gave us enough information that we put them in the system, but now they're not coming through. What's the problem? What do they want from us? They're interested in art, or they wouldn't have given us their information, but they're not quite connected in here. So knowing where we don't have a connection sometimes is very valuable. And we can't find it with the inner joins. We can only find them with the outer join. Now, we said that either a left or a right makes it an outer join. So how does that work? So given join table A on table B, left, if we say left join table A on table B, left will always put a row in from table A. And if there's not a match in B, we'll have a null for the column from table B. A right will always put a row in from table B. And if there's nothing in table A that matches B, then we'll get a null on whatever table A columns we have. We could just change the order of the tables and get a different result, right? So if I say join table B on table A, say I've swapped the names of the tables, then the left will put in a row from table B. Why? Because it's on the left. It's the left of the two. And right will always put in one from table A. So it's the order in your particular query that depends on whether you want to use a left or a right. That determines whether you want to use a left or a right. If you just decide you always like left joins, you can do that by swapping the names of the tables around, okay? but it's got to match. Once you have your query, once you say in the table, in the query, I'm going to join table A on table B, then the left or right will pick either table A or table B. Yeah, okay. Do you want to be consistent? How do you want to be consistent about it? Well, it depends. Different shops probably have different rules on the order they put tables and how they do this. But for our purposes, as long as you get to work right, it's okay. But there's not something special about the table. It's the order in the particular query. You could write one query where table A comes first and then table B. You could write a second query where table B comes first and then table A. So that's our outer joins. Outer joins are covered in Cronky on pages 272 through 277. Using an outer join may seem picky. A lot of courses don't cover it, but it affects the results that our customers see. If we leave out information our customer is expecting, it may have serious consequences. In Cronky, as the book notes on page 277, here's a quote from them. Let me just read it. It is easy to forget that inner joins will drop non-matching rows. Some years ago, one of the authors had a very large organization as a consulting client. The client had budgetary planning applications that included a long sequence of complicated SQL statements. One of the joins in that sequence was an inner join that should have been an outer join. As a result, some 3,000 employees were dropped out of budgetary calculations. The mistake was discovered only months later when the actual salary expense exceeded the budget salary expense by a large margin. By the margin of what 3,000 people were getting paid. The mistake was an embarrassment all the way to the board of directors. So they went for months thinking, oh, we have such a great budget this year. Now, part of the problem is, of course, they have too much confidence in the program. Unless the company had done something pretty radical, like closed a division or closed a factory or bought a company, something pretty radical, it should have stuck out. Hey, last year we had X employees, and this year we have X minus 3,000 employees, and we haven't made a lot of big changes. Yeah, being off by some percentage might be something, but that's a lot of employees to suddenly be down. It's something you should notice, and it's always good to ask these questions about data. Is there a reason, when we see a big data change, is there a reason we have a big data change? If there's not, then we should be suspicious about our code because it's real easy to make coding mistakes. Well, that's outer joins, and we'll get a little practice with it in the lab, and hopefully you'll find this useful.